Hello, I thought I'd make a short video on how to do art gases pretty easily, right? So the two things we care about are the PaO2 and the PaCO2. So obviously we need an arterial sample. We do not care about the SaO2. I do not care about that because it actually is derived from the PaO2. So you really want to use the right number. And the minimum SaO2 can translate to a PaO2 that is not acceptable if the PET stops hyperventilating, which we'll get to. All right, so the PaO2 reflects oxygenation, and the PaCO2 reflects ventilation. And obviously the question we want to know when we are looking at art gas is, does the PET need oxygen? So let's look at these numbers. So normal PaO2 is 80 to 100. Normal PaCO2 is 35 to 45. And this is generally accepted by the critical care college regardless of what your machine says. So forget the ISTAT normals. This is what we're talking about. So the lowest oxygen I want to accept is 80, and the lowest ventilation I want to accept is 35. And that's what's really important for us when we're examining an arterial blood gas in general to see if we need oxygen. So that's what we're going to address today, and that's the only question we're going to address today. So what's normal? Let's look at normal. So if a PaO2 is 90 and we are not hyperventilating, our PaCO2 should be right in the middle. Now I look at that and that's pretty easy. Normal, normal. Now what happens a lot to people is when they get an answer that's normal, where your PaO2 is 80, low normal, but your PaCO2 is low. And a low PaCO2, low CO2, let's say it's 20, that means you are hyperventilating. Now, intuitively, you know hyperventilating is going to artificially up this number, but that's the problem with only getting a pulse ox, is that you can't tell if this PET is hyperventilating or not. Now you can do a face mask end-tidal CO2, but a lot of you guys aren't necessarily aware of doing that. But when your PET is not anesthetized, if your PET is anesthetized, you can do a CO2 and see that they're hyperventilating. But anyway, so how do I know that this is not appropriate? Well, that's what you use the AA gap or gradient for. That is the equation you need if this is on room air. I spelled room wrong. Okay, so when I am looking at the AA gap, I'm looking at the alveolus and the artery. So this is your diagram of the alveolus and the little artery going by. How much oxygenation is picked up? So you're going to look at the gap. What misses? The oxygen doesn't get picked up from alveolus to artery. And it should be pretty small unless there's a problem of diffusion, like some lung lobes aren't diffusing at all, or there's a PTE or something like that. So this gap should be less than 20 in practicality. Okay, so let's look at this example here. We know this, right? This is 80. Little a is 80. So big A minus 80 is going to be our gap. But how do we figure out A? Well, the easiest way to figure out A is the alveolar gas equation. So the A, alveolar gas equation, is trying to figure out the gases in the alveolus, and it ignores nitrogen. So it's equal to the FiO2, the fraction of inspired oxygen, times the barometric pressure minus water vapor pressure. And that then you subtract, so that's your oxygen, but then you're going to subtract out the component that is CO2. So it's the CO2 divided by a respiratory quotient, or you can multiply by 1.2, but this is the way that I do that. In simple terms, that is 150, because that's what this comes out to, is 0.21, right, 21% oxygen, 760 is the barometric pressure at sea level, and 50 is the pressure of water vapor in the air that gets into the alveolus. That comes down at sea level to be 150 minus the PaCO2 over 0.8. Now we said that was 20, And so that number is going to be about, let's say that number is 1.2, so that's going to be 24. So 150 minus 24 equals 126. Now this 126 is the oxygen partial pressure in the alveolus. So now when we have an A minus A, we have 126 minus 80 equals 46, and normal is less than 20. So that's how you know that that is not a good blood gas. Even though when you looked at that number is a good number and that number is a bad number. So that's how you figure out if a pet needs oxygen.